Okay, so this is a nice problem from that showed up on the AMC 12A 2021. I think it's number 15. And so the problem is that you need to select a choir, and you have 8 tenors available and 8 basses available. And you want to select the number of choirs so that the number of tenors and the number of basses, the difference between them is a multiple of 4. So for example, 1 and 5 works because the difference is 4, is fine. And something like 1 and 4 does not work because the difference is 3, which is not a multiple of 4. And you need at least one person in the choir. So 0, 0 does not work, but 1, 1 does work. And so the solution I'm going to present involves some generating functions and roots of unity filter. I was able to actually post a solution on AOS, which is nice, but I actually did not get this on the actual competition because I was trying to solve it a different way. And I think I was in math class when I did this and I wasn't paying attention to math class. But anyways, onto the actual math now. The reason I like this solution is, well, because 1, generating functions and roots of unity are cool, but also 2, the answer ends up being a power of 2 minus 1. And so the other solutions, which are more like combinatorial, I don't think they sort of show why it should be 2 to the power something minus 1. But anyway, so again, what we want to do is find how many ways you can choose a choir so that the difference between the number of tenors and basses is a multiple of 4. And so the way you can do this is by setting up a generating function. So that is some function f of x, y is equal to the sum from a equals 0 to 6, from b equals 0 to 8 of, let's not use that, let's use 7n. So this is m equals 0 to 6, n equals 0 to 8 of a sub mn, x to the m, y to the n. So here we're just having these x and y's are sort of like placeholders, and the coefficient of x to the m, y to the n is the number of ways that you can make a choir that has m tenors and n basses, which would obviously just be 6 choose m, 6 choose m times 8 choose n. So because you can select m tenors out of 6 tenors, so that's 6 choose m, and you can select n tenors out of, 8 n bases out of 8 bases, so that's 8 choose n. And so that means that this sum is just the sum of 6 choose m, 8 choose n of this guy. And so the sum that we want to evaluate is adding up all of these coefficients for values where 4 divides m minus n. So we're going to use the generating function in some way to figure out what this sum is. Before we get to that, let's first just evaluate out what this generating function is. That is, because we have some things that depend on m and not on n, and some things that depend on n and not on m, we can split up this sum as being 2 different sums. So that's the sum from n equals 0 to 8 of 8 choose n, y to the n, times the sum from m equals 0 to 6 of 6 choose m, x to the m. Okay, so now you should be able to realize that this one is just y plus 1 to the 8th, and this is just x plus 1 to 6th. So this is our expression for f of xy, and we want to somehow isolate the terms for which 4 is a factor of m minus n. So here we have m and n as separate guys, but something that we can try to look for is some function g of x, where if we have g of x as being equal to like a0 plus a1 plus a2 and so on, then we can isolate a0 plus a4 plus a8 plus a12 and so on using what's called a roots of unity filter. So what we want to do is construct some function g of x so that the coefficients for every multiple of 4 would be the same as the number of ways that you can make a group, so that the difference in the number of players is that multiple of 4. So for example, a sub 4 would account for 1 tenor and 5 bases, 2 tenors and 6 bases, 0 tenors and 4 bases. So the number of ways that you can have it so that there's 4 more bases than tenors. Actually, I think we're going to do it so that's tenors minus bases, but either way works. And if you have negative coefficients, there should be x squared. And so if you have negative coefficients, so like if you have minus a4 or plus a4, x to the minus 4, and so on, then this will also account for that as well. So the way that we can construct our function g of x is by just simply doing g of x is equal to f of x inverse, and that will give you the sum from n equals 0 to 8, sum from m equals 0 to 6, of 6 choose m, 8 choose n, x to the power of m, x inverse to the power of n. So what we're doing here is we're just plugging in x inverse for y. And so x inverse to the power of n is just x to the power of minus n, but x to the power of m minus times x to the power of minus n is just x to the power of m minus n. So notice that g of x is some function that looks like, because n might be greater than m, you can also have negative numbers, so you can have a minus 8, a minus 8, x to the power of minus 8 plus a minus 7, x to the power of minus 7, and so on. And the highest number that you can get is m equals 6, n equals 0, so then that'll be a 6, x to the power of 6. And so if we look at a minus 8 plus a minus 4 plus a 0 plus a 4 plus a 8, a8 does not exist. So if we sum up these guys, for example, a0 is all the numbers where m minus n is 0, and so m minus n is 0 means that 4 divides m minus n. Here again, m minus n is negative 4, which means that you have 4 more bases than tenors, and so you have again that 4 divides the difference in the number of players. So now we want to sort of add up all of these guys. And so what we're looking for is that if this is equal to the sum of, let's call it like bk x to the k, then we want to take the sum over all k is congruent to 0 mod 4 of b sub k. And we can do this by using roots of unity filter, and so the formula is that this is 1/4 times the sum from for over all the values z, where z to the 4th is equal to 1, of g of z. So this just means that you take g of I, g of negative 1, g of negative I, and g of 1, add them all together, divided by 4, and then you get all of the terms where the coefficient is congruent to 0 mod n, or in other words, 4 divides the exponent, not the coefficient. So I made another video on that if you want to see where the formula comes from, but we'll just apply it here. So notice that we use f of x comma x inverse to sort of write this in terms of x to the power of m minus n. But we can also use this to explicitly find out what g of x is by looking at this. So this is just going to be equal to x inverse plus 1 to the power of 8 times x plus 1 to the power of 6. Okay, so now let's use our formula. So we want to have that our answer is equal to 1/4 g of I plus g negative 1 plus g negative I plus g of 1. Okay, so now let's plug in all of these in. So this will be 1/4 g of I, which will be I inverse plus 1 to the 8th times I plus 1 to the 6th plus, so g of negative 1 is just going to be, for example, you can look here, negative 1 plus 1, which is 0, so that's 0 to the power of 6, so that's just 0. And then here you have g of negative 1, so that'll be negative I inverse plus 1 to the power of 8 times negative I plus 1 to the power of 6. And here you have g of 1, which would just be 1 plus 1 is 2, so that'll be 2 to the power of 8 times 2 to the power of 6. Okay, so now notice that I inverse is equal to negative I, because I times negative I is 1. So that's just negative I. And negative I inverse is equal to I for the same reason. Negative I times I is equal to 1. So these two almost look the same, except that you have you have I plus 1 to the power of something times negative I plus 1 to the power of something. And here you also have I plus 1 to the power of something times negative I to the power of something. Except the exponents are a bit different. So what we can do is we can just sort of rewrite this as 1 minus I squared times 1 minus I to the 6th times 1 plus I to the 6th. And we can rewrite this as 1 plus I squared times 1 plus I to the 6th times 1 minus I to the 6th. So now these two are the same thing. So we can factor this out and look at the sum 1 minus I squared plus 1 plus I squared. And this will multiply out by I plus 1 to the 6th and I minus 1 to the 6th. But it turns out that's not necessary because this evaluates to 0. That should be a 1, not an I. So why is it evaluate to 0? Well, you can calculate it out. This comes out to negative 2I. This comes out to 2I. And so those guys evaluate to 0. So what that means is that this evaluates to 0, this evaluates to something A, this evaluates to the same thing but it's negative, so that's negative A. And all we're left with is g of 1 divided by 4. So what that'll be is 2 to the power of 14 over 4. And so that should be your answer, 4,096. Except that we want to make sure that there's at least one player on the team, or on the choir, I guess. So that is, there are no players on the choir when you have 0 tenors and 0 basses. And so that corresponds to the coefficient of x to the 0, y to the 0, which would be 6 choose 0, which is 1, times 8 choose 0, which is also 1. So there's only one possibility where you don't have anyone on the team. So you have to subtract that off. It gives you 4,095, and our final answer is 95. And yeah, that is my explanation of this problem. And again, what I like about it is that this generating function sort of almost explicitly gives you that it should be a power of 2, instead of just summing up some binomial coefficients and seeing that somehow it's a power of 2. And also, again, generating functions and retrievability filters are really nice.